Hi guys. So today let's discuss American call options on dividend paying stock. So let's assume that 0 is less than equal to T1, less than equal to T2, less than T3, all the way to Tn. Okay, let's assume that T1 to Tn are the dividend paying dates. So the stock can only pay a dividend on these dates. Okay, it cannot pay a dividend at time 0. And we further assuming that stock doesn't pay a dividend at the expiration of the option. So capital T gives us the expiry of the American call option. Now let's further assume that just before the dividend is paid out, the stock is trading at S of Tj minus. So at time Tj, just when the dividend is about to get paid out, the stock just before the dividend gets paid out is trading at this level. And let's further assume that the amount of dividend that we get is given by Aj times S of Tj minus. Okay, where Aj is a number between 0 and 1. So this is the amount of dividend that's going to get paid out at time Tj. Now we know that when the stock pays a dividend, the value of the stock goes down by the dividend amount. Okay, so what would be the value of the stock after the dividend gets paid out? And that's denoted by S of Tj. This is going to be the price of the stock before the dividend, just before the dividend, and minus the amount of dividend that gets paid out, which is S of Tj minus. Okay, so this is very simple. S of Tj is equal to 1 minus Aj times S of Tj minus. Okay, so that's how the stock before the dividend and after the dividend are related. Okay, let's further assume that in between these dividend paying dates, the stock is modeled as a geometric Brownian motion. So let's consider a time period Tj less than equal to T less than Tj plus 1. Okay, during this time there is no dividend that gets paid out, and we're going to model the stock as a geometric Brownian motion. Okay, and if this is modeled as a geometric Brownian motion between dividend paying dates, then we can write S of T is equal to S of Tj e to the power of sigma W tilde of T minus W tilde of Tj plus R minus half sigma square T minus Tj. Right? This comes from our geometric Brownian motion. Now from this we can see that just before, when we reach Tj plus 1, just before the dividend gets paid out, the stock would be trading at S of Tj plus 1, and that's going to be given by this Tj. And here instead of T, let's substitute Tj plus 1, sigma W tilde Tj plus 1 minus W tilde Tj plus R minus half sigma square Tj plus 1 minus Tj. Right? Very simple. So instead of T, I'm just substituting Tj plus 1, and I'm putting a minus here because we're modeling the stock as a geometric Brownian motion, and that would give us the value of the stock before the dividend gets paid out. Okay, that's denoted by S of Tj plus 1 with this minus sign right here. Okay, so that's the first thing. Now let's assume that, now if this is STJ minus 1, then we know that the value of the stock at S of Tj plus 1 after the dividend gets paid out is going to be equal to 1 minus A. From here we can see it's going to be the amount of dividend that we get paid at J plus 1 multiplied by S of Tj plus 1 minus. Okay, so this was the value of the stock before the dividend gets paid out. We get, from here we get Aj plus 1 times STJ plus 1 minus this much amount of dividend. So the stock price after the dividend gets paid out, which is denoted by STJ plus 1, is going to be given by this formula, which is very similar to what we have here, right? Now similarly, we can also see that if we only consider, Tn less than equal to T less than equal to T. So if we are looking at only the last time period, Okay, so we just got paid dividend at Tn. At maturity, we said we're not going to pay any dividend. So if I want to now look at what is the value of the stock at St, this can be written as S of Tn e to the power of sigma W tilde T minus W tilde Tn, right? Plus R minus half sigma square multiplied by T minus Tn. Clear? Okay, so now we are considering a American call option that expires at time capital T. Okay, and as I said, between Tn and T we don't have any dividend payout, right? So we looked at the situation when no dividend gets paid out in the previous lecture, and from there we saw that between Tn and T the stock is modeled as a geometric Brownian motion. Hence we can say that the discounted value of the stock, which is e to the power of minus RT times S of T, where T belongs between Tn and T, this is a martingale, right? It's a martingale because we don't have any dividend paying out between this time, and we've talked many times before that discounted value of the stock is a martingale. So that's what I've written down here, and we're not getting any dividend, right? So this holds true. And also we saw in the last lecture that the discounted value of the intrinsic value of an American option is a submartingale when there is no dividend, right? In the previous lecture we basically talked about that if that time we considered American options on non-dividend paying stock, and this period no dividend gets paid out. So the result that we got in the previous lecture applies here as well, right? And that time we said that the discounted value of the intrinsic value of the American option, here we're dealing with American call option, the intrinsic value is going to be given by S of T minus K plus, and we said this is a submartingale, right? So if you haven't seen the previous lecture, you go ahead and see that. And that time we discussed and we showed that this is a submartingale when the stock doesn't pay any dividend. So from the submartingale property, we can see that expected value under the risk neutral measure of e to the power of minus R, instead of small t I'm going to write capital T. So I'm substituting t equals to small t equals to capital T here, and S of T minus K plus given information at time t. Okay, this is greater than equal to e to the power minus RT ST minus K plus, right? So the process has a tendency to rise, and this is exactly what I showed you in the previous lecture, and that's what we mean by this being a submartingale, right? Expected value given information at time ft is greater than equal to the process at time ft, right? Or time t. This is the submartingale property. So now we can simplify this a little bit here. We can divide both sides by e to the power of minus r small t. In that case, what we'll get here, we'll get e to the power of minus r t minus t, right? S of capital T minus K information at time t. This is greater than equal to S of T minus K plus. And as we discussed in the previous lecture, we know that a European call option would have this payoff, S of capital T minus K, right? And we know that the discounted value of a European option would be a martingale, right? And from the risk neutral pricing formula, we'll see that this is the price of a European option, European call option, right? Because the payoff is that of a call. So this is nothing but the price of a European call option, and this would be the intrinsic value of the American call option. So American call option we can exercise at any point in time, and if we exercise the option at time small t, this is the payoff you're going to get, right? So this is the intrinsic value of American call option. And as we discussed in the previous lecture, since the value of a European call option is greater than the intrinsic value of an American call, it doesn't make sense to exercise the option because the option is worth more by holding it to expiration, right? Because if we exercise, we're going to just get the intrinsic value, but this is greater than the value of the European call option, which we cannot exercise till expiration, is greater than the intrinsic value, or the so there is no advantage of exercising the American call before expiration. So that early exercisability of an American call option is basically worthless, right? In case of a time when the stock is not paying dividend, right? And if this is the case, then we know how we price a European call option, right? We've talked about Black-Scholes model earlier, and we know that if you want to price a European call option on a non-dividend paying stock, that price is given by C of Tx is given by x time n d plus, and this is a function of tau, which is tau is nothing but time to maturity, capital T minus T, x minus k e to the power of minus r t minus t n d minus tau and x, right? This is our Black-Scholes formula, price of a European call. And as we are saying that during this time period, the price of a European and American call is going to be exactly the same, because early exercisability of an American option doesn't really have any value. So we should never exercise American call option during the time period when there is no dividend, right? Hence, the value of the American and the European call option should be exactly the same. So the European call option is given by this, and we are saying that because American call option, the value should be the same. This basically gives us the value of the American call option during this time period, Tn to capital T, and that's why I'm denoting this by C subscript n, okay? And we know that D plus minus is given by, this is a function of tau, and x is nothing but 1 by sigma square root of tau log of x by k plus r plus minus half sigma square tau, right? This is our Black-Scholes. This is a Black-Scholes formula, right? So just to recap, what we've done is we're looking at this last time period when the dividend is not getting paid. Then we saw that the value of an American and a European call option should be exactly the same. And we know that using Black-Scholes model, the European call option is priced using this formula. And hence the value of our American call is also going to be given by this formula during this time period. Okay?